welcome. I'm Jackie Jacob. I am the coordinator for the Small and Backyard Flocks Community of Practice, and I organize the monthly webinars. As you see, we have switched to Zoom from Adobe Connect, so this is our first time trying it. Feel free to give me any feedback on ease of use with it. That would be appreciated. Okay, this month's webinar is on small hatchery management, and Dr. Tony Pescatore from Department of Animal and Food Sciences at the University of Kentucky, who has many years working with the poultry industry, large and small, and he will be talking today. So it's all yours, Tony.
All right, thank you, Jackie. Today we're going to talk about small hatchery management. And when we're doing that, what we're going to talk about is why do you want to get into it and some of the logistics of managing a small hatchery. So first of all, why do you want to have a hatchery, or why do you want to operate a hatchery? There's many different reasons. It could be producing quality chicks for your own operation. It could be producing quality chicks for sale. It could be that you don't want to have broody hens in your operation, so you want to do artificial incubation. You may want to perpetuate endangered breeds by doing intensive reproductive management. You may want to do something in this nature for education programs like chicken incubation in classrooms and things. Or you might just want to do it for personal enjoyment. Each one of these is a valid reason to be involved in a small-scale hatchery, and we need to make sure we match what we're doing with what our purposes is. The advantages of incubation is that we can take, or of artificial incubation, is we can take a large number of eggs, incubate them together, and hatch a large number of chicks at the same time. So we can make a flock, or we can make a group of chickens that we want to produce, whether it's for lay or meat or perpetuating a breed. We can also coordinate the time of hatch so that we don't have chicks hatching when we don't want them to. By being able to set all the eggs at the same time, incubate the eggs, and then hatch the eggs, we can coordinate it when our hatch is occurring and when we have chicks. And the other advantage is that we can increase hygiene. By having an artificial incubator or incubation, we can increase hygiene by having a separate facility for that, away from a poultry house or nesting brooding hen. And when we're talking about, what we're really doing is we're mimicking the broody hen. And we're doing everything that the broody hen does. When you think of a hen sitting on a group of eggs, she's doing everything we're going to do in a small-scale hatchery. She provides proper temperature. She provides the turning of the eggs. She provides the moisture that's necessary to keep the eggs from developing and not to dry out. She protects the eggs. And she then also allows air to get to the eggs, so she provides ventilation. And these are the 5 things that we're going to do in any type of incubation situation, whether it's a broody hen or a large hatchery or a small hatchery. We're going to provide the correct temperature. We're going to turn eggs to keep them, the yolk centered in the egg and the embryo centered in the egg. We're going to regulate how much moisture the egg loses. We're going to protect the egg, and we're going to provide the needed oxygen, as well as remove CO2 that the chick is making. So let's talk about some terminology when we talk about this. The first terminology you're going to see is hatchery. That's a building that's used to incubate or hatch egg-laying species. In the commercial industry, these are large, massive buildings. But on the small scale, a hatchery could be a single room. It could be a garage. It could be any part of a thing. But we were talking about where we're going to incubate the eggs and we're going to hatch the eggs. Incubate is to provide heat, ventilation, humidity, turning of the fertilized eggs to develop an embryo. So incubation is when we're going to provide those things necessary for that egg to develop. We're going to provide heat, ventilation, humidity, and we turn the eggs. The term incubator or setter is a mechanical device that's used to incubate eggs. And we'll go over this a little more when we look at different types of machines. But the incubator and the setter is when we are going to not only provide those things, but we're going to turn the eggs. The hatcher, as opposed, is the place where the eggs spend the last 3 days of incubation prior to hatching. And in most cases, we're going to stop turning eggs 3 days before the scheduled hatch. A hatching egg is any egg that is produced to create a new individual. And people get a lot of concern about that, is that when we start looking at these, a fertile egg is an avian egg that has a developing embryo. What that means is that we have to have a component from the male and we have to have a component from the female, and that embryo starts developing. And that's one of the things about a fertile egg, is that that embryo is already developing by the time the hen lays her egg. Because fertilization takes place somewhere between 24 and 26 hours prior to the egg being ovipositioned or laid. So that embryo is actually going to be grown as we get that egg from the hen. The infertile egg is any avian egg that contains only the female half of the gamete. We still have the female contribution to the infertile egg, but there's no male component. The term set it means placing an egg in an incubator or a group of eggs placed in an incubator at the same time. The next thing is pipping, and that is the act of the chick penetrating the shell membranes and the shell with its beak. It's the first time that the chick is going to break out of the egg. So those are the terminologies. And the key point is that for good hatching eggs, we have to have the male and female gametes present, and that fertile egg is already developing before we get a hold of it, because it's that 24 or 26 hours that egg is in the oviduct, and that body temperature of the hen is somewhere between 105 and 107 degrees. So she's incubating that egg before it's produced. So let's start with hatching eggs. One of the key points that on hatching eggs is to get the best eggs you can. And one of the things that we need to look at is that we have a known reliable source. And that known reliable source can be identified by the National Poultry Improvement Plan breeder flocks or hatcheries. So we want to get our hatching eggs from participants in the National Poultry Improvement Plan. If we're producing our own, we want to get that certification ourselves, going through either our state animal health office or our local NPIP. You can get blood tested for your birds and get registered into NPIP. That gives you some sense of quality of your flocks, and to your customers that you have some assurance that you are doing things right. To keep good hatching eggs, the first thing that needs to be done is to collect hatching eggs frequently. As often as you can physically do it, that's the best thing to do, is collect hatching eggs frequently. When you do collect eggs, use clean flats and containers. Perfectly plastic flats, things that can be washed. And use clean flats each time you collect it. When you go to pick up hatching eggs, or before you better use them, before you handle and after you handle hatching eggs, you want to wash your hands and make sure you have clean hands. The other thing is we're trying to get nice, clean hatching eggs. So if you have birds that are on the floor and you want to produce hatching eggs, you want to make sure you have adequate nesting boxes with clean nesting material. And as a rule, we don't want to use dirty eggs as hatching eggs because they can bring contamination into the incubator. If they're lightly soiled, you can remove organic material by hand, but I do not encourage you to wash the eggs. We can physically use sanding paper or a simple moist handy wipe. That's the best thing you can do to those eggs. We get to the hatching eggs. There are egg transmitted diseases or vertical transmitted diseases that can come from the hen to the chick through the egg. These include Salmonella pylori, Mycoplasma gallisepticum, Mycoplasma synovi, Mycoplasma malagraris, and Salmonella enteritidis. And when I referred to the National Poultry Improvement Plan, one of the things that we do is we test for Salmonella pylori typhoid in the breeder flock. This is a very classic egg transmitted disease, and it is the basis of the MPIP. The other options on this list are all optional. The other choices are all optional, but the Salmonella pylori is something you have to participate in. In addition to these egg transmitted diseases, NPIP also is where we have our low path avian influenza program. So with the newest problems we've had with avian influenza in the state, most states require for transportation some type of low path AI monitoring program. So if you're interested in getting into a commercial hatchery or shipping chicks over state lines, you need to be MPIP, you need to participate in the Salmonella pylori program, and you also need to make sure, depending on the state, the low path AI program. So what makes an egg unsuitable for hatching? Well, one is that it's a dirty egg. And we already talked about that a little bit, that the dirty eggs are not suitable for hatching because they're going to bring in a large bacterial load into the incubator, into the hatchery. Cracked eggs are not good for hatching because they can leak content. They can also have bacterial contamination get into the egg. We don't want to incubate small eggs because the chick is dependent on the yolk size is related to the chick size. So if you incubate small eggs, you will get small chicks. It's about a 65% relationship. So if an egg is 60 grams, 65% of that will come out to chick. So you'll have maybe a 40 gram chick. We don't want to incubate large or double yolk eggs because of the double yolk eggs more than likely will have 2 embryos developing, and eventually they get in the way of each other. And you'll see on videos on the internet that they can break the chicks open and that they'll survive, but they get in each other's way. They cannot get oriented to pip the egg in the right place. Poor shells are another problem because in the incubating process, the egg loses moisture. And if they're losing too much moisture, it could be detrimental to the developing chick. We also don't include grossly misshapen eggs because there's a greater chance that they break in the incubator. So some of the factors that can influence hatchability at the farm are first the breeder nutrition. I can't emphasize enough that you must use a higher degree of nutrition for your breeders, because one of the things about an avian egg, when we have a developing chick inside that egg, every nutrient other than oxygen has to be present in that egg for that chick to develop. And we want to use a good high quality layer feed or breeder feed to provide all the vitamins, minerals, protein, energy that that developing chick needs to develop. We have to worry about disease. If any of those diseases like that we listed that were egg transmitted, we have a problem with the disease causing poor quality chicks. However, there's many other diseases like infectious bronchitis or Newcastle disease that will ultimately impact the quality of the egg, which will then also impact the quality of the chick or the ability to incubate. In order for there to be a fertile egg, there has to be mating activity. And that is one of the things that occurs is if they're not being active mating, there's not going to be fertile eggs. We can damage the egg. Once we damage the egg, it's no longer a candidate for incubation. And then the correct male to female body weight. If we have over obese hens or we have obese males, there's less chance of them mating correctly and fertilizing the egg. And back to the mating activity, we want to make sure we have a proper mating ratio of males to females. Usually for light hens, it's about 1 to 10 male to female. For the heavier hens, it's probably 1 to 8. The other thing is when you have multiple males, there can be increased social interaction or fighting that reduces fertility because they have other things on their mind like fighting and aggressiveness as opposed to doing their job. Egg sanitation, making sure the eggs are clean, making sure you're getting your eggs in the nest, getting the hens to nest properly. And then we have egg storage. And the breeder farm has a major influence on what happens in the hatchery because a high quality hatching egg is the first spot on trying to build that chick. So, hatching eggs. One of the first things that should be done as you're storing eggs or you're bringing eggs in is maintain records. You want the collection date. You want to make sure you have the breeds identified. If you're using different pens, you want to make sure you identify where those eggs came from so that you can keep records and you can review what's actually happening with regards to your flock. If we're going to group eggs together, we want to store them in a designated area, whether that is in an egg cooler or it's in a basement. One of the things we're trying to do is store them in a designated area. One of the things about eggs is if there's toxic chemicals or offensive chemicals, they can absorb it and it may interfere with their ability to hatch. Storage temperatures somewhere between 55 and 65 degrees. A lot of people will sit there, can I store hatching eggs in the refrigerators? Refrigerators operate at 40 degrees Fahrenheit or below. That's too cold for the embryo. The whole point of refrigerating or getting the eggs down to lower temperatures is we're going to try to put the chick in suspended animation so that we stop the development until we want the development to occur again. And that's what the whole purpose of providing that temperature. You can store eggs up to 14 days without a loss of hatch. The longer you store the eggs, the lower the hatch. But we can probably do it within a week, 10 days without much loss. Once we start going over 14 days, you will lose some of your hatchability. Lower storage, if you're going to do long storage, one of the things that's a trick to do is to tilt the eggs. Say your eggs are in an egg carton or an egg crate. One of the things to do is put a piece of 2x4 or two 2x4s under one end of the crate, put them at an angle. The next day, reverse it so that the eggs are being rotated. And the reason we do that is that we try to make sure that the yolk stays center into the egg. And if we're storing eggs, particularly if we're storing them in a cold environment, one of the things we want to do before we set eggs is we want to allow that hatching egg to come to room temperature before setting it in the incubator. And the reason we do that is we don't want the eggs to sweat, where we have condensation on the egg when we put a cold egg in a warm incubator. So some of the principles of hygiene that I talk about when we're dealing with a hatchery is that there is a bacterial load that comes with the eggs from the breeder house. That's a given because of the type of environment they're in. So when we bring that egg into our hatchery or into our designated room that's got our incubators, we need to realize we're bringing in some bacteria along with the egg. And another key point is microorganisms like bacteria and fungus and the developing chick grow well at the same temperatures and humidity. Bacteria likes to grow at the same type of environment that the developing chick likes to grow. So we need to understand that the bigger the load of bacteria we bring into the system, the greater the chance that we have a problem. The other thing is that hatching eggs is a dirty, dusty process. Because of the down or the fluff that's given off, because of the egg residue, all these things provide a chance or a vehicle to bring bacteria into the situation. So hatching is a dirty, dusty process. And the other one that I always think is one of the principles we should operate on is you can never be too clean. The cleaner we are, the better we reduce that bacterial load, the better we operate our hatchery, the better we are in regards to producing chicks. So let's talk about sanitation in there. A key point is to start with clean eggs. Along with that, we want to start with clean equipment and make sure that we clean the equipment as we go through the season. We also want to eliminate clutter so that we don't have much extraneous materials being stored around where we're going to hatch chicks. One of the things over my years that I was visiting small hatcheries is we are usually confined to space. They like to store their egg flats or their hatching boxes, all these type of things in the same room. And that clutter is places where bacteria can hide. The down and the egg residue can carry microorganisms. So when we are cleaning out a hatchery or we're cleaning up after a hatch, those two things we need to make sure we get them out and we dispose of them properly. When designing a hatchery for small operations, putting it somewhere where the walls and the floor should be washable so that we can clean as we hatch chicks, we can clean before we start and make sure that the materials don't harbor bacteria. One of the things is if you have concrete floors or concrete walls, make sure they're sealed with a sealer so that because concrete is porous without the sealer and water can be absorbed in there, and along with the water you can have bacteria. Same with cracks and crevices in the floor. Make sure you seal them. The other principle is that the hatcher, where we actually hatch the chick out of the egg, is the dirtiest place in the hatchery. It is the dirtiest area. And going along with that, the hatcher must be cleaned after every hatch. This I cannot emphasize enough. When we start seeing chick quality problems or we start seeing reduced hatches, most of the time, especially if people are hatching multiple hatches over a season, it's when they don't clean the hatcher or has a buildup of hatching residue in the hatcher that we have problems. You must clean the hatcher after every hatch. And along with that is the ventilation, the air coming in and the air going out. A lot of people would like to have their small incubation areas in a building, or they may have it in their basement or in a room in their house. Air is coming in there. Make sure that it's clean air coming in, and more importantly, if you're hatching in that area, air is going out. So and if you're within your house, you can blend your air together. So it's always good to install filters on the air going back to the return if you have central air conditioning or central heating, so that you're trapping what's coming in there. People don't think about that, but when we're hatching, it's a high bacterial load, it's high dust. Make sure you're filtering the air coming in and filtering the air going out. So when we start talking about this, the hatchery layout becomes very important. We really have 4 areas in a hatchery that we're going to deal with. One is egg receiving and storage. Where do we put eggs prior to incubation? Then we can have the incubation area. Then we need an area where we're going to process chicks or pull the hatch when they hatch. And then we need an area where we're going to clean and wash up, because, as I said, we're going to clean that hatcher every time. So we need to have those things. And this is when you're starting out, is to think about where you're going to store eggs, where you're putting your incubators, where you're going to pull your chicks, and where you're going to clean and wash. Ideally, we have separate areas for all these functions, but the need to use multi-purposes areas in a small hatchery we're aware of that. But what we want to do is move from the dirtiest to from the cleanest to the dirtiest, so that if we're talking about eggs, hopefully they're clean. The incubators themselves, other than the hatcher, is the cleanest. The setter is clean. When we bring that chick out, we're more dirty. When we get to the idea of washing, that's the dirtiest. And we never want to backtrack through. So we don't want to clean and wash near where we're storing eggs. We want to go the other way. So we want to make sure we're always moving from clean to dirty. But the way we design that is, you got to think about is where you're going to do each one of these 4 functions. And again, cleaning and washing is very important. When we store eggs, I wanted to go over a little bit about where exactly do we start with and what are we doing. When the hen's body temperature is 104 to 106 degrees, so we go from the fact that egg is very warm, it's laid in that hen house or in that barn, it's going to go down to room temperature somewhere between 75 and 85. We want to take it down to 70 degrees at least, and we want to get it into the storage somewhere in the 60s. We want to preheat the eggs before we put them in the machine. So when you think about it, we're going all the way down to that 55, 65 degree range. then bringing the egg up to room temperature again, and then putting it back in the setter. And most incubators are designed to run between 99.5 degrees and 100 degrees, little less than what the bird's body temperature is. So when we store eggs, the main effects is if you store eggs, you can prolong incubation time. So on the average, for every day you store an egg, you're adding an hour of incubation time. And you may want to take that into account, because if you're mixing eggs together, where you have fresh eggs and stored eggs together, and they're set together, you're going to have a long hatch time. So we try to make sure that we understand where the eggs are. If you have a whole lot of eggs that are stored for 14 days and you have fresh eggs, it's almost like having two different hatch times. The longer you go after 6 days, you lose about 0.5% per day, so of hatchability. So if you go for 14 days, you might lose 4% hatch. And then anything over 14 days, we're going to see an effect on chick quality. We're going to see an effect on depressed body weights for those eggs that are stored over 14 days. And when we talk about storage, the longer we're going to store, the lower the temperature we want to store at. But if we're only going to store it less than a week, anywhere from that 60 to 68 or so, 65 degrees is going to work for those eggs. One of the things that people forget is that air exchange occurs across the eggshell, and the pores in the eggshell allow that gas exchange. When the egg is incubating, carbon dioxide comes out of the egg, and oxygen goes into the egg. At the same time, water is lost by water vapor while the egg is in storage. So the loss of carbon dioxide and water increases as we store those eggs, and will have an impact on hatchability and chick quality. So you're operating your hatchery. What are things that affect it? The sanitation, how we store the eggs, the damage we do to the egg, how we manage our incubators and setters, egg sanitation, and how we handle the chick once it hatches. So the 4 things that an incubator must provide is the correct temperature, the correct humidity, an adequate gas exchange, and the regular turning of eggs. Usually we like to see the eggs turned about 4 times a day. That's what a machine with a turner will do. And if you don't have a turner, you need to turn them at least 3 times a day, if not possibly 4 times a day. So one of the things that we're looking at is the temperature of the incubator. It's usually fixed, but as we modify that temperature, we might modify it because we want to increase or delay the hatch. Stored eggs take longer to incubate, and that increased hatching time will be added. Again, it's about 1 hour per day of storage. And then the size of the egg. The larger the egg, the more it takes to incubate the egg. And what the temperature is when we incubate eggs influences the hatchability and the hatch time. The blue line is the average hatch time. The black line is the average hatchability. If you look at that, the ideal hatch time is about 20 and a half hours or 21 hours. That is called 21 days, I'm sorry. And the hatchability is in the 90 percentile. And that's occurring between 99 and 100 degrees. That's our target for temperature. If we go much hotter than that, we increase hatchability a little bit, and we shorten our hatch time. Once we get over 101 degrees, we start seeing a decline in hatchability and very early hatch dates. The same with lower temperatures. If we incubate at low temperatures, we'll decrease hatchability, but we greatly increase the amount of time that it takes for that egg to hatch. So when we have delayed hatches, one of the things we look at is what temperature the incubator is running at. Another thing that we have to worry about is the age of the breeders. The older they are, as they breed over a season, the lower the percent fertility or the hatch of fertile eggs. And then the other thing we're looking at is there's an optimum weight loss. An incubating egg will lose about 10 to 11% of their water loss as they incubate. So that egg is getting lighter along the way. The other thing people forget is that in the first half of incubation, the hen or the egg is requiring heat to be added to it. In the latter portion, when she's ready to hatch, she requires heat to be dispensed because heat is being produced by the developing embryo. So if you look at that curve, as we get towards the latter portion of the incubation, we got to dispel heat, and we got to dispel and make sure we have increased ventilation. So things that affect early hatch include extended preheating periods, setting eggs too early, incorrect setting and hatching temperatures, hot spots inside the setter and hatcher, seasonal temperature changes affecting hatch environment, too many fertile eggs in the hatcher. When we have too many eggs, we can't control the temperature if we don't have the ability to cool it. Along with that, factors affecting a late or delayed hatch is that we set the eggs too late in the day, we have too low a temperature, we have incorrect ventilation, we have seasonal temperature changes. All these things are things that affect it. Or delay with delayed hatching. One of the things I do want to talk to you about is the type of equipment that is out there. Depending on what you want to use or what you want to do depends on what type of equipment. And we can range into new equipment versus used equipment. Many of the small hatcheries will go and find used equipment, and that's fine. Make sure it's clean, make sure it's got a functional thermostat, and it's reliable. The other thing is there's lots of new brands out there. There are a lot of new incubators out there. Which ones are we going to use? At the same time, one of the things that we have to decide on with new versus used is what is the material that the incubator is made at. One of the things that we look at is if you're starting out small time, you start using things like the Hoovabator or Little Giant incubator, which is a small incubator. It's made out of styrofoam. It's a relatively cheap incubator, and it's a small time. If you want to really get into the business, you want to step up to whether it's a cabinet type or a cabinet type, and how many eggs it's involved in. And then we have to look at the control systems. One of the things we look at is in the older incubators and some of the newer ones, they use a mechanical thermostat, whether it's a mercury a mercury switch or a temperature wafer. Those are mechanically means of regulating temperature. And all it means is that when temperature is obtained, the switch will either the wafer gets expanded and cuts it off, or the mercury changes. These mercury switches and wafer chips, wafer discs, are been the model for the industry for years and years. They are reliable, except when the wafers start leaking gas, or they will not be reliable. But more than that, right now, there's lots of companies that are marketing electronic thermostats, where the electricity is turned on and off based on those thermostats. So if you have a choice between the mechanical methods or the electronics, it's best to go with the electronics. The materials, we already said there's styrofoam. If you get an old incubator, the traditional old incubators from the 40s, 50s, 60s was wood. Whether it was redwood or cedar, it was some type of rot-resistant wood. And many of those are still around, and they have done a very good job over the years. We also have some steel cabinet ones with steel or it's metal clad, or we have fiberglass clad. And when we go from styrofoam towards fiberglass clad, we're increasing our ability to wash and clean the incubator. Now, the other thing that we have to look at is what exactly is the setup that we're going to deal with. You can have a single stage incubator where you set all the eggs together at time of transferring to the hatcher, which is 3 days before the end of incubation. You stop turning the eggs or take the turner out, and you have all the eggs in there. Those single stages are fine. Again, they have a hard time regulating temperature near the end, and you can only hatch at one time for chickens 21 days, for turkeys 28 days. So you're limited to it. Some companies are marketing a combination setter hatcher, where you have the setter as part of the incubator, and then below it or to the side of it is the hatcher. Those were very popular in the 50s and 60s. They're getting to be popular with some of the newer ones that are coming out from overseas. The disadvantage of those are that the incubator, the setter, and the hatcher are together. And I already told you that the dirtiest part of the incubation period is when the chicks hatch. And if you have your dirtiest pieces of equipment attached to your clean pieces of equipment, it's hard to clean properly. And you can have cross-contamination as well. From there, you have the separate hatcher and the separate setter. Those are the ideal situations where you have the ability to set eggs and hatch eggs in two different machines. You have the ability to break down the hatcher and clean it as well as you can. That's all right. What we were going to talk about is that One of the things that we look at is good records. We want to record what we have.
While you're doing that, Tony, I don't know if Jackie might be able to speak to this, but Jay Walter says a wine cooler seems to be good for storing hatching eggs.
That would be true because that does have a wide range of incubation time or temperature range, because you're trying to do that. And there's a lot of nice little wine cooler machines that are out there right now. All right, one of the things we worry about is the egg size. I mean, not the chick quality. If you're starting to see unhealed navels, unabsorbed yolks, any type of deformities, red hocks, any type of dehydration, or we're starting to see a mushy abdomen, we need to investigate what we're doing with the incubator. Especially unhealed navels and mushy abdomens, there's more than likely a sign of bacterial contamination. Working with that, we want to make sure we are cleaning that hatcher. If we have any eggs that are exploders in the setter, we need to clean the setter as well. If we're starting to see dehydration or deformities, we may be running the incubators too hot.
There's a question, Tony. Could you repeat the comment on breeder age?
Breeder age. As a breeder goes through age, they are going to lose they will lose hatchability. So the older the breeders, the lower the hatchability. Then when most of the time, when we start lighting birds, that's one of the things people sometimes forget, is that we usually bring our flocks into production somewhere between 20-24 weeks of age. At the same time, hens do not reach their mature weight until about 32 weeks. So one of the things in that first 8 weeks that they're producing eggs, you're not only feeding the hen to produce eggs, you're still feeding her to reach maximum body size. So that's when she's got the highest nutrient demand, and that's when we need to make sure she's getting good nutrients. And then the other thing that happens is that when we light breeders or we start lighting a flock, usually it takes somewhere between 2 and 3 weeks after stimulatory light for the male to be active. It takes 2 or 3 weeks longer for the males to become fertile compared to the hen to produce her first egg. So when you start looking at the fertility of eggs in the front of a production cycle, many times they have a low fertility rate because the males are not fertile or not producing sperm cells yet.
Do we have any more questions? No? I just want to let everybody know that the August webinar is August 10th, and it will be common money wasters with poultry, ways to reduce costs. And Chrissy just asked any insight on candling.
Candling. If you're doing white eggshells, it's a good idea to do it at 7 days to remove the infertile eggs. If you're doing a dark shelled egg, whether it's brown or green or any of those colors, do it after 10 days, 14 days of incubation when you got a better chance of seeing the embryo. It's always an idea to pull those. It's always a good idea in that first to second week to candle the eggs in order to remove any contaminated eggs, particularly eggs that have mold growth or bacterial growth in there, and get them out of your incubator to prevent exploders. And it also gives you a good handle on what fertility is.
If the egg is very light, handle carefully.
Yeah. One of the things that happens is the bacteria will use up the moisture and will grow there, and they don't weigh very much.
exploding eggs stink.
Yep. And then the other thing is there's key components for development of the embryo. That first, by day 2, all the organs have to be in place, or the organs, the systems are starting to form. So we see mortality at day 3. We see mortality at day 14 when the embryo goes from being horizontal in the egg to vertical. And then we see it again at 19 days or 20 days when the chick is starting to pip. So when you start looking at your management of the incubators, those are the areas where we start seeing the peaks in mortality.
Okay, I think we're running out of time here, but if anybody has last interesting question, feel free.
I'll just let folks know that we are recording this, so it'll take me a couple of days to process it, and we'll have a link to the recording on the Learn event at learn.extension.org.
Okay. And I said August webinar is August 10th on common money wasters with poultry and ways to reduce costs. Ron King out of the University of Wisconsin will be giving us a presentation. Thank you all for coming, and I hope we'll see you again next month. Thank you very much, Tony. You did an excellent job.
Thanks, everyone. Bye-bye.